7.3 covers what's called the law of cosines. Law of cosines is useful when in a triangle we know two sides, two side lengths, and the angle that is included between those two. So we're looking at a side angle side situation, okay? If we are, and actually we can use it for side, side, side as well. So essentially, if you know two of the sides of the triangle and either the angle between them or the third side, we can use law of cosines. So our first step is we're going to find the third side length using law of cosines. And then we are looking for the smaller of the two remaining angles. If you remember on any triangle, just sketch a general triangle here. So let's call this X, Y, Z. So this will be little x and little y and little z. Okay, so on any triangle, the biggest side has to be, which in this case would be the x, has to be across from the biggest angle. And then the second biggest side, let's say z is the middle one, has to be across from the middle angle. And then the shortest side has to be across from the smallest angle. So when it says find the smaller of the two remaining angles, we determine which one that is by finding which of the two sides that corresponds to that angle. So the one across is going to be smaller. The reason we have to do that is if we try to find the larger angle, we won't know if it's going to be, and this is assuming that the known angle is acute, okay? But if we try and find the larger unknown angle and it is the largest angle in the triangle, we won't know whether it's, whatever we solve for when we do sine inverse, we won't know if it's going to be an acute angle or an obtuse angle. Remember, like in law of sines, we had the ambiguous case where we could have, this side could be right here, or it could kind of swing in and be right here and it'd be the same length. And so if we're trying to solve for that big angle, we won't know which one to use just based on the side length. So anyway, you find the smaller of the two remaining sides using either law of sines or law of cosines, okay? And then subtract from 180 to find the third side, okay? And then the last option is if we know all three side lengths, and we're going to use law of cosines. Again, here we're going to start with the largest angle. If we end up with a cosine of the angle is equal to a negative value, then that means we know that we're in quadrant 2, meaning we have an angle that is obtuse. And if cosine of the angle is positive, then we know that our angle will be acute. So we won't have to worry about that ambiguous case, okay? All right, so let's look at what law of cosines says. So law of cosines is, again, if we have an angle that's between two known sides, c squared just means the unknown side, okay? So this is the unknown side. And again, don't get hung up on, which one's A, which one's B, which one's C, because it could change based on which ones go in which spots here, change based on what information you know. Okay, so c squared is equal to a squared plus b squared minus 2ab cosine c. Okay? Similar to the Pythagorean theorem, actually this first part is the Pythagorean theorem, but then we have to subtract this additional part, 2ab cosine c. Okay? All right, so then if I wanted to solve for cosine c, then really I'm just rearranging this equation. So I would start by subtracting both of these from both sides of the equation. So I would have c squared minus a squared minus b squared, and then I would divide that whole thing by 2ab. Now that negative cancels out, so we end up with a squared, stop doing that, a squared plus b squared minus c squared all over 2ab. Okay? All right, so let's go ahead and apply these. We've got a couple of triangles here. This one is a side angle side situation because we have two sides and we know the angle between them. So I'm going to label the side across from angle A as lowercase a. Okay. And then remember our steps say we find the third side using law of cosines, and then we're going to find the smaller of the remaining angles. It's a little bit bigger. Okay, so third side using law of cosines, so that's going to be a. Okay, so a squared is going to be equal to, or this side squared is going to be equal to the sum of the squares of the other two sides, so 4 squared plus 6 squared minus 2 times those other two sides times cosine of the opposite angle or the given angle. Cosine of 61. Okay. And so that becomes, so we've got 16 plus 36 minus, so 8 times 6 is 48, and then cosine of 61. Okay, and I'm going to try to avoid typing things in the calculator until the end, or until, until as long as possible so that I don't end up rounding too early, okay? And so then, so this is still a squared, so we're going to take the square root of both sides. So type all of this into your calculator. We end up with a is approximately, this whole thing is equal to about, I'm not going to use the calculator on the screen, but I've got this already, so about 28.729, etc. Then take the square root of that. Don't round until after you've taken the square root, and this comes out to be about 5.4. Okay, so this side is about 5.4. Use the unrounded number though in later calculations. Okay, so now we're going to use law of sines to find, and then I'm looking at either angle C or angle B. I want to find angle B because I'm going for the smaller one because I might not know if that is acute or obtuse. Okay, so sine of 61 degrees over, I'm writing 5.4, but I'm actually going to keep this same number in my calculator. If you're unsure if you would like to store numbers and are unsure how to retrieve them, let me know. I can show you how to do that pretty easily. It's the STO arrow button that's right above your on key, and then you can just pick a letter. I usually pick X, and then you can retrieve that without having to round anywhere. Okay, so this is equal to sine of angle B over the side across from that, which is 4. Okay, solving this gets us that angle B that comes out to be about 40.4 degrees. And then to find the last side, angle C, we're going to subtract from 180. So 180 minus 61 minus 40.4 comes out to be 78.6 degrees. So here's the measure of angle C, here's the measure of angle B, and here's the missing side length A. Okay. All right, for the next one, we are using law of cosines again, and here we don't have any angle measures. Okay, so we are going to start by solving for the largest angle. The largest angle is the one across from the biggest side, so that's going to be angle B. Okay, so using the formula given, do this here, we have cosine of angle B is equal to 4 squared plus 8 squared minus 10 squared. Okay, so the two adjacent sides squared, add those together, then subtract the square of the opposite side, and then we divide by 2 times the adjacent sides again, so 2 times 8 times 4. Okay, and so when we evaluate that, we get negative 0.3125, okay? So because this says cosine of B is a negative number, that tells me that when I do inverse cosine of this negative number, that's going to give me something that is in quadrant 2, meaning we have an obtuse angle, all right? So then do, in your calculator, do the cosine inverse of negative 0.3125, or the non-rounded version always, which comes out to be about 108.2 degrees. Okay, and then we can use law of cosines again, or you can go back to law of sines now that you have the measure of one angle. I'm going to use the law of sines here. So let's find angle A. We do want to find the smaller of the two remaining angles. Okay, so I'm going to do angle A. So let's do sine A over 4 equals sine of 108.2, but again, don't use the rounded version. 108.2 over 10. When we solve this, we get that that measure of angle A is about 22.3 degrees, and then subtract from 180 to stop that to get the last side, or sorry, the last angle, which is, what do we still need? C. So C is 180 minus 108.2 minus 22.3, which comes out to be about 49.5. There we go. Okay, so angle C, angle A, and angle B. Okay, with these two, we just need to draw our triangles first. They don't need to be perfectly drawn to scale, but as long as, you know, we can kind of tell where things go. I'm just going to draw triangles that kind of look equilateral. Actually, no, I'm not. I'm going to make one side longer. So my short side will be A, which is 9.47. My longest side will be B, which is 21.2. And the middle side will be C, which is 15.9. So that makes this angle C, this angle A, and this angle B. Okay. So we have all three side lengths. We do not have any angles. So law of cosines to find, first of all, the largest angle. The largest angle is going to be angle B because it's across from the biggest side. So cosine of B is equal to the sum of the squares of the adjacent sides, so 9.47 squared plus 15.9 squared minus the square of the opposite side, 21.2 squared. And then all of that is over 2 times the adjacent sides, 9.47 times 15.9. Okay, we plug all of that in and we get that, and then do the inverse cosine of all of that, and we get that the measure of angle B is approximately 110.8 degrees. Okay, so there's one angle. And then again, you can use law of sines or cosines to find the smallest angle. I'm going to use law of sines because we've done quite a bit of practice with that. So we're looking for angle A since it's across from the smallest side. So sine of angle A over 9.47 is equal to sine of angle B that we just found over side B, which is 21.2. Okay, solve this and we get sine A is equal to about 0.417. So the measure of angle A, the inverse of that, comes out to be 24.7 degrees. And then again, subtract from 180 to get the third angle, which is C. So 180 minus 24.7 minus 110.8. And we get about 44.5 degrees. Okay, so angle C, angle A, and angle B. All right, the last one here. I do have an angle and I have two sides. Because this is letter A, I know that it's the angle that's included between these two sides. So I have side angle side here. Okay, so when we label or when we draw this, I'm going to put angle A down here. And then that's at 41.4 degrees. And then let's see, 2.78 will be, this is B, whoops. It's across from angle B. And then angle C up here, this is 3.92. And then this is side A. All right, so first we find the third side. So A squared equals, and then it's first the sum of the squares of the adjacent sides. So 2.78 squared plus 3.92 squared minus 2 times A times B. So 2 times not A and B for this, but the adjacent side. So 2 times 2.78 times 3.92 cosine of the included angle, which is 41.4. The screen a little bit there. And then let's see. This comes out to be that A squared is approximately 6.745. So square root of that. So A is about 2.60. Oh, I don't need units on those because those are angles. Okay, so 2.60 meters for unknown side length. Okay, and then now we can use law of sines to find the missing angles, and we want to go for the smaller of the angles. So we're going to find angle B. So sine of A, 41.4 over side A, what we just found, 2.60, is equal to sine of B over 2.78. Okay, so multiply by both denominators, do the inverse sine. We get that sine B is 0.707, etc. And the inverse of that, that's actually 1 over root 2. So the measure of angle B is 45 degrees. Okay, and then triangle sum theorem for the third side, or sorry, third angle. So measure of angle C equals 180 minus 45 minus 41.4, which is about 93.6 degrees.